The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
Hello and welcome back to the Ben Heck Show. Over the past few months, we've been working on a ZX Spectrum computer project. First we changed out its RAM, and then we rebuilt it onto its own little breadboard, basically rewired the whole computer. In today's episode, we're going to finish the project and make it into its own little portable handheld unit. Some of you have had issues with me saying Z instead of Z, so I tell you what. In this episode, every time I say Z, I'll play 1 minute of the online game Standing in Line 3D. All right, let's get this project done.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
Now I'm working on the video analog circuit for the ZX Spectrum. On the original console, it's pretty much everything in this area right here. It takes the YUV from the ULA chip, which is the video chip, translates it into a composite PAL signal that can be output on the television. Now we have a PAL screen here, so we basically need to reproduce all this with modern components. I'm using the same LM1889 chip. Unfortunately, it requires 12 volts, but we'll worry about that later. So what I've done is I've replaced all of this by using surface mount components in this same area. See them all? They're fairly small, but they are there. So we have our luminance and sync. Then we have our, I think it's red minus green and blue minus green coming into this circuit here. And they're combined into a single composite output signal here. And again, I'm not using this part yet because we really don't need it. Although the end result will be these two modules plugged together to recreate the entire spectrum in breadboard form. All right, so I'm gonna do a test. I'm gonna turn it on. When you boot up the ZX Spectrum, you get this black and white screen. That doesn't help us for testing purposes. So I'm gonna type in paper. All right, looks like the color is working. That's good. Had Felix locate the right transistors to match the originals. All right, cool. Now that we know that our replaced video circuit works, I'm going to move the ULA over to this circuit and then completely detach myself from the ZX Spectrum. ZX Spectrum. It's ZX Spectrum. There are 4 lights! In order to test the functions of the ZX Spectrum, I need to have the keyboard attached. Therefore, I've gone ahead and made my little miniature keyboard. That will be in the final unit. I've used a piece of engraving plastic and attached all the tact switches to it. On the back, I've hand wired the matrix, which is quite simple. There's basically 5 columns, 1, 2, 3, 4, 5, and then they also go 1, 2, 3, 4, 5. And then there's 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. So I'll attach wires coming off of this miniature keyboard here, and there'll be a plug which will attach the ZX Spectrum circuitry. Once I'm able to attach the keyboard to my circuitry, I can make sure everything works. But the idea is I will keep all of this original ZX Spectrum stuff intact. Therefore, it won't be destroyed. In a previous episode, we made this half of the unit. This is basically a Z80 computer. Then we made this, which is what really makes it a ZX Spectrum. We have the ULA video chip, its RAM, the decoders for the RAM, the flip-flop to drive the RAM, and the video conversion chip that actually creates the composite signal. Then we have several capacitors and transistors, which are used to modulate the signal, and a port for inputting the tape data. So these halves are tied together. We have our voltages attached, and we're gonna see if we can get to output on this screen. I'm gonna see if I can switch ROMs. The text will change. Yep, all right. Notice if I squish it, see, it's got a couple noise issues, but I think we can resolve that. But the important thing is that it works. I mean, there's a lot of wiring on this, and I'm surprised that it does work, actually. I've never hand-wired a complete computer before, until now, I guess. The next step is to attach the keyboard and make sure that we can change colors and the color is still working, and then I'll try to load a tape. I've carefully copied the matrix from the original keyboard and wired it manually onto this. We basically have rows and columns. And the rows are actually addressed through the address bus, believe it or not, the top 8 bits. Again, the Sinclair Spectrum was made to be very, very cheap. So we attach that to the address bus here, going through some diodes, and then the columns actually attach to the ULA. So there's only one port on this thing, if you can believe that, and it lets you do the sound and the keyboard. So there's some pull-up resistors here as well. So I had to wire this in a certain way because I have to think about how it's going to go back together. It has to fold over like this. So I'm thinking these wires can tuck in here, the screen will go here, but we also need room on the side for the batteries. So I think this is a pretty good compromise. All right, let's test it out. Because with the keyboard, we can test not only the colors, but also try to load a tape. I'm gonna turn on my screen, turn on the specky. The specky, that's the cool thing to call it, I guess. All right, let's see if I can, obviously these aren't labeled yet. Paper space, oh, I don't know, 1. Oh, cool, all right. Paper space 5. Okay. Next, I need to test the tape loading. There's an entire section of the schematic which involves the cassette input-output. They're very confusingly labeled. There's mic and ear, and microphone is when you're outputting to the tape recorder, and ear is when you're inputting, which doesn't make a lot of sense, but you know, whatever. So microphone we're not really gonna need because the point of this isn't to write to tape. We just wanna load games in. So I'm just going to wire up the ear part of the circuit, but what I discovered was I have to remove some of the inline passives, such as this 100 nanofarad capacitor, otherwise it won't work correctly with modern equipment. Here's the revised circuit. The headphone jack goes through a resistor, and then there's some diodes, and also we have a capacitor filtering it to ground. Then there's a pull up to 5 volts, which will keep it basically at a certain level unless you're actually playing sound through it, and then that goes to the ULA chip. All right, so let me give you an example of this working. I'm gonna power up the Spectrum. I'm gonna plug in this headphone jack here. I downloaded an app which allows you to play Spectrum tapes based off zip files using your cell phone. So I'm gonna plug my cell phone in. I'm not gonna start the file yet though. Okay, let's see. Load space ... Okay, it's ready for input. Let's give it this, run. Okay, these color bands are what we want to see. That means it's working. You'll also hear the tape coming through the speaker because on the schematic you can see the speaker is hooked up directly to the tape input and vice versa. Again, this thing was made as cheap as possible. It appears like it's loading. Let's see what happens. Nice, Galaxian. This tape only takes about a minute. If I had more time, I could probably add an SD card loader, but I don't have more time. It's already been a 3-part episode. It's time for it to be finished. And this will be very much, it's a stock specky. I mean, it's been completely rewired, but it's still specky. But is it a ZX specky or a ZX specky? That's the question. This is what amused people back in the 80s. Along with pet rocks and Rubik's Cubes. Haha, you did not get me, Aryan. I kill all Aryans. No one's gonna know what that means. All right. Next, I'm going to install this 12-volt step-up regulator. It's going to take the 5 volts and bump it up to 12 because we need 12, unfortunately, for the color signal. Nothing else needs 12 volts, but this should be sufficient. That way we can just have a single 5-volt input. Now it's time for a tech timeout. For today's tech timeout, I thought I would show you my latest 3D printer. The company that makes this is called CNC, and the printer is called the Orion. It's a Delta printer, which means it uses 3 arms on these beams in order to move the head around. It's actually a lot faster than an XYZ Cartesian system. In fact, it's so fast, it can usually exceed the speed that the plastic can be extruded. So that's actually what limits its speed, not really all the mechanics around it. I like how it has a smaller footprint than other 3D printers. And it is pretty quick. And it has a heated glass bed, which is really nice. So yeah, looks like a great printer. Once I get it all dialed in, I'm sure we'll be using it quite a bit on the Ben Heck Show. Not long ago, in this very galaxy, capturing and visualizing measurement data took time and energy that robbed engineers of the ability to focus on the real engineering challenges. Today's engineering environments require turnaround times that are faster than ever before. These demands call for efficient test tools to speed up productivity and get the job done right. A smarter, more efficient way to work is here with the new BenchView software from Keysight Technologies, formerly Agilent's electronic measurement business. No longer use your cell phone to record screenshots, simply connect and click a few buttons to quickly capture and export data. BenchView enables you to easily drag and drop measured trace data for near instantaneous and accurate replication on your TrueForm function generator. Use BenchView Mobile as a remote display to troubleshoot and then validate faster than ever before. Learn how BenchView and TrueForm function generators can accelerate your testing by checking them out on element14.com. Here are the parts for the case. I have a front plate and I lasered all of the keys on it, so I had to laser cut this piece because I needed a lot of detail. That connects to the front half, which I made out of my favorite white filament, and it has mounts for the keyboard. So those will glue together. This is another plate. I didn't need this, but it just kind of breaks up, the image. It makes it look a little bit more interesting. And this stuff interconnects to the rear case. See how there's a lip? That lip will snap into here, like so. And there's a slight chamfer on where the edges meet. That's called a glamour line, because what happens is the two pieces might not be perfect, and by might not be perfect, they won't be perfect, even with injection molding. So if you put a slight chamfer on there, so instead of having like two straight edges butt up to each other, you have like two slightly curved edges butt up, and therefore the deviations in consistency are hard to see. It's basically a trick. So yeah, in the back I put a piece of plastic. Did this for a couple reasons. One, if you print a large surface like this, it might not be very consistent. And two, it's so people can see that it's a real hand-wired unit, not emulated. So I'm gonna glue this plastic in place and glue together the rest of the case. So here I go. Here I go, here I go, here I go again. Never gonna get it, never gonna get it. Pulse pounding gluing action. I've used a knife to score the surface of this, that way it will receive the glue well. Just gonna put a few drops down because we don't want it to leak through the edges. I'm going to install the keyboard into the case before I glue on the front panel to make sure that the holes for the keys are aligned correctly. There's not much gap, so there's not much room for error. I have to do it pretty much right. Whatever I do, it must be right. These keys were all mounted by hand and they're on a grid, which means there's lots of opportunities for them to be misaligned. Make sure every one of them clicks. The reason I use tack switches is because if these were square keys, it'd be really easy to fat finger it because they're so small and close together, but the tack switches, you can feel each individual one. Yeah, and they have a low profile. All right, so with that in place, I'm actually gonna flip this over and glue it from the inside just to make sure it is right and doesn't move. So I'm putting the glue on from the inside so it'll seep under the walls, but I want to put in so much that it seeps through the walls to the other side. So I'm going to go around and do all four walls this way. But that's why I always use liquid super glue, not gel, because liquid super glue will soak into things, which can also be a negative, but if you're used to it, it's usually a positive. Because if this was super gel, I'd have to put all the gel down and then squish it together. But in this case, I've aligned it first and then I'm gluing it. Okay, all the buttons. Well, if any of them are gonna be misaligned, it's gonna be the ones on the end. and they're all good. All right, I will continue to do the other sides. I'm gonna move over to my workbench to stuff parts inside of the case. I pulled this wire out of an old AV cable. It's shielded. Even though it's not gonna go a very long distance, I'm gonna use this shielded wire for the video just to make sure that it's well shielded. I need to start thinking about the best way to arrange things. So when it's open, the screen will be over here, which means this shielded cable should be able to go about this far. That's one of the reasons I want it to be shielded, is because the case has to be able to be opened, but that means the cable needs to be longer, and if it needs to be longer, it needs to be shielded. And then the charge circuit that Felix wired up, which we'll talk about more in a little bit, right here, it's gonna sit right there. So I should move my power lines across this way. So everything's kind of arranged as it's going to be in the case. So the wires are as short as possible, but we're still able to open it up. I want to make sure that all of my wires are connected before I put this into the case. It's not like I can't remove it, but still. So this is for video, this is for the built-in speaker, keyboard, ground, and 5 volts. And again, it's going to do the 12-volt conversion right here, so it's all one piece. So this is the back of the case with the glamour window. I should have given this a little bit more space, but I think I can make it work. That wizard came from the moon. Hey, there. Oh, it's emulated. It's like, nope, it's not emulated. Glamour window. Okay. These little posts are meant to support the PCB. I made them separately just because it's easier to put them in manually as I go than to draw them into the case. Because as usual, we only have so much time to do this. So I'll put 4 of these around the corners, one there, there, and then I will put a screw in to secure the PCB. I've partially installed the LCD in the front panel. And these holes aren't speakers, they're basically just for airflow. Okay, so what I gotta have to do next is attach the charge circuit. Felix designed this yesterday and we laser painted it. So it has 9-volt charge here. This goes to the batteries. This will go to the screen, and this will go to the spectrum. And this is a charge indicator light. I'm going to try to install it right here. I'm going to take this battery pack, slice it in half, and put a battery on either side. That's about it. Forget about your brother. I have him now. I am the Goblin King. So if I want to drive Allison crazy, well, there's actually many ways to do it, but one surefire way to do it is to misquote the movie Labyrinth. Here, listen to the wails of torment. Forget about your little brother.
No!
That's like the only line I know from that movie. Let's see if this battery has a charge. Da-da-da-da. Yes, it does. I want to be careful not to short it out, because if I do, I can forget about the baby. Isn't that what he says, is forget about the baby? We have our 2 cells side by side alongside our spectrum. Hopefully there's not too much noise. Most of our power wires are run down the bottom. And out of the charger circuit, we have 7.5 volts for the screen. And then I've hooked up the 5 volts for the ZX Spectrum. And then there's a power switch. We have the voltage going to the screen here, the video going to the screen here, and the shielded cable, and this will attach to the buzzer speaker once we put the case together. Now to finish it up. Final connections, we have the speaker wired up, our keyboard's in place. We want to make sure that we keep the video signal away from anything else as best we can. It's kind of unavoidable. I'm going to kind of curl these wires a little bit so they'll fold in upon themselves when we close the case. Added the heatsink to the ULA since it gets hot. I taped over any exposed metal surfaces that might contact something. I think we're ready to put this together. This post we'll push the reset button, which is down here. So I made a 3D printed post and shaft for that. Time to close it up. And that concludes one of the most complex projects we've ever done on the Ben Heck Show. We took a Sinclair ZX Spectrum computer, added some modern RAM, a custom ROM, turned it into a breadboard, wired it all by hand as basically a new computer, added some batteries, made a custom case and screen and keyboard to make a portable ZX Spectrum that turned out pretty nice. Now it's time to play some games. I can use this cable with my cell phone's headphone jack and play old tape images to load games. Gotcha, suckers. Chubby rain. The aliens come down in their raindrops. So what I can do is I could find, all sorts of images online of the tapes and play them on my cell phone and basically play any old Spectrum game that I want. Sweet. Nice, I cleared the attack wave. This game is just Space Invaders, but occasionally one of them drops down. Speaker's nice and loud, that's good. These guys are shooters. That's all the time we have for today. In our next episode, we're going to try to build our own cell phone. But now, let's check the Z counter and see how many minutes of standing in line I have to endure. Let's see if I can live through this. Click to start. I can jump, I can punch myself in the face, and I can move. Okay. Oh, I can look behind me. Great. Well, I'm not the last person in line, at least. Oh, the head moves with the keyboard. Oh, I'm starting to fall asleep. There we go. Oh, this is so boring. I'll never say Z again. Oh crap, I just said it. Uh-oh, my character looks like he's kind of dead. Can I punch the other people, maybe? No, don't. Ah! I guess I've got to keep playing. Maybe there's a cheat code. God mode. Oh crap, I hit the spacebar accidentally. I'm gonna wait till I'm almost asleep and then punch myself in the face. Man, this is worse than Desert Bus. Oh! Why would I scream if I'm falling asleep? I wonder if they have this game for the ZX Spectrum. Oh crap! I can't take it anymore! Looks like I'm gonna be here a while. Kill me! Oh no, I'm falling asleep! Hey Ben Heck Show fans, beginning in September, the Ben Heck Show will no longer be available on the Revision 3 network. Be sure to change your dial to watch us on YouTube or over on the Element 14 community as we continue to bring you great weekly builds and bonus content. That's about all I can say right now. Here's how the keyboard attaches. Wait, did we cover the keyboard at all yesterday? Take that, alien. End cut. That's a wrap, folks. Hey, can you reactivate the fan of dreams? I don't have anything more to say. Oh, you're a mosquito. Yes, I'm just a mosquito. Well, I suppose you're going to bite me. Even if it's not too much bother. I could use a good nip. Careful what you wish for, Jennifer Connolly Chronicles. You know nothing, John Crow. Snow, whatever your name is. Snow and Crow sound alike.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.